Jai Hind everyone. I am Vivek Kumar Pansari, Assistant Professor in Department of Mechanical Engineering at Ajay Kumar Garg Engineering College, Ghaziabad. In the lecture series of Fundamentals of Mechanical Engineering, which is the subject in first year in both semester with the name of BME 101 and 201. Today I am trying to cover the video or the topic on the stress-strain diagram. Okay, so stress-strain diagram, as we all know, that is the part of mechanics of solid or strength of material. So basically what we study in strength of materials, or what do we want to understand in strength of materials. Okay, so in strength of material, we talk about the relation between stresses and strains. And stress and strain I already covered in my previous videos, which you can see on the AKGEC Digital School channel. Okay, so what is stress and what is strain? So basically here we are talking about the deformable bodies. So whenever a body is subjected to any deforming force, it offers resistance against the deformation, and that resistance per unit area offered by the material is known as stress, and the corresponding deformation with respect to the actual shape and size of that body is known as strain. And the relation between how these two terms are related, in any case, either it is a normal loading or it is the shear loading or it is the twisting, in any of the case, how the stresses are developed and how these stresses are related with the strains is known as strength of material. So study about this. So when I am talking about the stress and strain relation, then a law comes in our mind that is known as Hooke's law. Okay, so Robert Hooke was the name of the person or the mathematician who gave that law कि within the elastic limit, stress is directly proportional to strain. What does it mean? So whenever a body is subjected to any deforming force, it offers stress, it offers resistance against the deformation. Okay, so that is what the stress, and that stress is increasing continuously as the deformation is increasing. So within the elastic limit, the stress offered by the body is directly proportional to the strain developed. If I denote the stress by sigma, generally we denote stress by sigma, and the strain by epsilon. So sigma is directly proportional to epsilon. And if I am going to draw the curve between the stress and strain within the elastic limit, that will be the straight line. The curve between the stress and strain, in which range? In the range of elastic limit. And the meaning of elastic limit must be clear to us. Elastic means after removal of deforming force, if material regains its actual shape and size, then we say the material is elastic. So if stress की value elastic stress से elastic limit से ऊपर नहीं जा रही है, in that condition we will say the stress is directly proportional to strain. But the relation between stress and strain is not only up to the elastic limit. For making any kind of deformation, permanent deformation, we have to move beyond the elastic limit. So in that condition, if we have to study the relation between stress and strain, then we have to go with the complete stress and strain diagram. So I hope this point is very clear. Hooke's law, within the elastic limit, stress is directly proportional to strain. And if I am drawing the diagram, stress-strain diagram between stress and strain, it will be a straight line. So now I am moving towards the finding out the stress-strain diagram for the material, which is mild steel, a ductile material in the UTM, in the universal testing machine. So the stress-strain relation of any material is obtained by conducting a tensile test, because I have chosen the ductile material. So ductile materials are offering more tensile strength, so the tensile test is preferred. So stress-strain relation of any material is obtained by conducting tensile test in the laboratory under the UTM with the standard specimen. Okay, and the behavior, it is not necessary the material is of showing the same behavior in the tension or in compression. So, the material's behavior will be different in both the condition. For that, mild steel, as I told, I have chosen. So, mild steel specimen I have taken for the tensile test with what? With the universal testing machine, So, these two parts will be fixed in the UTM, and by applying the load gradually and at regular interval, the extension is measured. So, whenever, if this is the specimen, if I say this is the specimen and these 2 points are fixed, and through the UTM it is extended. So, what 2 things will be observed? Obviously, the stress will be there against the deformation, and simultaneously we are observing the extension, the change in length, because we are interested in both stress and strain. So, in mild steel, okay. Now, coming to the point. So, when I perform this particular experiment on UTM, on the mild steel, okay, tensile test, which test I am performing? I am performing tensile test on mild steel with the help of UTM. So, we are going to get this type of stress and strain diagram. So, now let us see. Stress is taken on the y-axis, strain is taken on the x-axis. Stress, it is the resistance per unit area offered by the material, okay, and strain that we are measuring with the help of the extensometer and the change in length on this. Different points are shown here, the point P, point E, point Y1, point Y2, U, B. Okay, so this is the how the stress is changing with the strain. That's what I am going to discuss in detail, point by point. Okay, what is the meaning of point P? What is the meaning of point E? So, now let's come to the details. Okay, here I hope it is visible also in this diagram also. So, the point P in this stress strain diagram is the limit of proportionality. It means the mild steel, whenever is subjected to any load, the relation between stress and strain up to the point P is linear. It means the Hooke's law is obeyed perfectly, and the curve from O to P will be which type? It will be linear, क्योंकि stress or strain directly proportional है. So, at point O, whenever there is no strain, the stress is 0. As the strain is increasing, the stress is also increasing, and up to the proportionality limit, stress and strain both are increasing in the same proportion, and the diagram is a straight line from O to P. Then after point P, we are reaching to the point E. That point is known as elastic limit. And the meaning of elastic limit is very clear. If I say after removal of deforming force, the mild steel will regain its actual shape and size which was in the beginning, but it is not necessary that from P to E the stress and strain are directly related, directly proportional. So, it is not necessary कि P से E के बीच का curve straight line हो. Okay. So, now the difference between these 2 points P, that is the limit of proportionality. The curve is linear. From P to E, the elastic limit is there up to point E, but stress strain curve is not necessarily linear. Okay. Then what else? After elastic limit, we are reaching in the range of plastic deformation. In the plastic deformation, what does it mean? After removal of the deforming force, material is not getting its actual shape and size. So, beyond point E, if the stress is increasing beyond point E, then the plastic deformation of material starts, and slowly it is reaching up to the point Y1, which is known as upper yield point Y1. So, this is the stress at which the load starts reducing and extension increases. This, okay, and beyond point Y1, beyond point by 1 which is upper yield point, the plastic deformation तो point E से start हो गया, but perfectly plastic behavior of material start beyond the point by 1 which is known as upper yield point. Then another point is there, that is the lower yield point. At this stage the stress remains same but strain increases. As we are observing that stress is slightly decreasing, but the deformation in the mild steel is more as compared to the change in strain or change in stress. So what we are observing, that is what known as, and mild steel is reaching to the point by 2 which is known as lower yield point. Then beyond point by 2 which is the lower yield point for the material mild steel, the strain hardening of the material start. In that region, what is starting? What is starting? That I am writing strain hardening. Strain hardening of the material start. It means material is offering more resistance with the deformation also. Deformation भी हो रहा है, straining भी हो रही है, and offering more resistance also. So after yielding, okay, it is written over here also. Strain hardening of the material start in the region by 2 U. Then the material is reaching up to the point U. That is what known as ultimate stress. So the maximum stress which a material can resist. Okay. And at point U, the neck formation of the material starts. Neck formation. What does it mean, neck formation? Neck formation means sudden reduction in the cross-sectional area in a particular region. Okay, sudden reduction. As we know that our neck ka area, it is the lesser as compared to the body. So if the cross-section area is reducing suddenly, then obviously the value of stress is increasing rapidly. So that is what the effect of necking, and that's why the material is reaching up to the break point. So beyond point U, which is the ultimate stress, again I am reading out, this is the maximum stress the material can resist. At this stage, the cross-sectional area at a particular section, that's what I told, that is what the necking यहाँ से start हुई, reducing very fast. This is called the neck formation. Okay, so that we will be observing here in the next diagram. Okay, obviously the neck formation is starting from the lower yield point itself, but the main deformation we are observing beyond point U. That is what the necking area. So after neck formation, after ultimate stress, the stress strain curve started sloping down. Which is stress strain curve? The curve between nominal stress strain curve. Nominal stress strain curve, which is also known as engineering stress and engineering strain. ये दो terms भी अभी बताने वाला हूं. What is this? Engineering stress and strain or nominal stress and strain. So which curve is sloping down? The curve nominal stress and strain. And what it is? Nominal stress strain या engineering stress and strain curve. Okay, nominal stress. So whenever the stress is calculated with respect to original cross-sectional area. Original cross-sectional area. Suppose I say this is my specimen in the beginning, then a load is applied. So if I am making all the stress calculation with this cross-sectional area, then it is what termed as nominal stress. Okay, or the engineering stress. And neck formation की वजह से जो stress हो रहा है, that stress is true stress, and that true stress is calculated, or the instantaneous stress is calculated on the basis of actual cross-sectional area. What does it mean? Suppose after the extension, its cross-sectional is reduced. Cross-sectional area has got reduced. So if I am calculating the stress at a particular point on the basis of area of cross-section at that instant, that is what known as instantaneous area, instantaneous stress or true stress. So that is what the difference between these two terms. So what is written over here? A stress strain curve for the nominal stress strain will slope down beyond point U, but the true stress strain curve is increasing because cross section is reducing very fast. That's what is necking. That's what is necking. Okay, so that is okay. I hope this point is clear. So again, I am coming to the point. What is the point P? Limit of proportionality. E, limit of elasticity. That is clear. Beyond point E, the plastic deformation of material starts. After point by 1, which is the upper yield point, the perfectly plastic behavior of the material start. But at the point by 1, the mild steel is not stable. So there is a slight decrease in the stress, and mild steel is reaching to the point, the stress is reaching to the point by 2, and that from by 1 to by 2 region, that is what known as yielding. Beyond point by 2, the strain hardening of mild steel starts. It means along with the straining, along with the deformation, material offers more resistance. Then mild steel stress is reaching to the point ultimate stress, which is the maximum stress mild steel can offer. Beyond point U, the sudden reduction in the cross section start, which is known as the necking. Because of the necking, the true stress is increasing very rapidly, very fast, but the nominal stress is coming down and reaching to the break point. So the stress at which finally the specimen fail or break, that is what known as breaking stress. So I hope these points are clear up to the nominal stress and true stress. These terms must be very clear to us. Okay, now I am coming to the some specific features of the stress strain diagram. Okay, if unloading is made, अभी हम बात कर रहे थे loading की, but now if I am talking about the unloading within the elastic limit, obviously within the elastic limit क्या होगा, material same path को follow करेगा. But if the specimen is stressed beyond the elastic limit and unloading is performed, then the unloading curve will be a parallel line. किसके parallel? Stress strain curve की जो elastic limit तक line थी, the parallel line will be drawn and that is intersecting the strain abscissa at the point F dash. So that is what known as permanent set. So if unloading is made within the elastic limit, the original length is regained, the stress strain curve follows down the loading curve. If unloading is made after the loading the specimen beyond the elastic limit, पहले ही बताया, it follows a straight line parallel to the original straight portion and as a FF dash. So that is what known as permanent set. It means that much of deformation strain will remain with the material. That property, that characteristics can be used to find out the yield point, to locate the yield point of various materials. If the yield point of any material is not known, that what I have taken 0.2% of the maximum strain I have taken on the strain line, and from there draw a straight line which is intersecting the stress strain curve at point F, and that point F is known as the yield point for that material. क्या बोला मैंने? Because there will be a 0.2% of the permanent set, and that can be used 0.2% of the maximum strain. From that point, draw a line parallel to the straight line of stress strain curve, which intersect the stress strain curve at point F, which is known as the what? Yield point for that, or the ultimate point for that material. Okay. Then stress strain curve for, अभी हमने बात की stress strain curve किसके लिए? Ductile material के लिए. Now I am talking about the stress strain curve for different brittle material. So high carbon steel, because of the more carbon content, cast iron, aluminium, concrete, all these are the brittle material. So the stress strain curve of brittle material like cast iron, in these material there is no appreciable change in rate of strain, there is no yield point, no necking takes place, and so the curve is, तो आप देख सकते हैं, there is no necking, there is no yield point. So yield point and ultimate point both are coinciding. Okay, so this is the stress strain curve for, कभी कभी पूछ लेते हैं ductile material के साथ साथ brittle material का भी stress strain curve. So in that condition we must be able to differentiate between these two. Okay, what is the second purpose of the study of stress strain curve? Because it is kept in the UTM where we are continuously monitoring the elongation also. So percentage elongation we can get. Okay, L, that is the length before deformation, L dash, that is the length of the object or specimen after deformation. So L dash minus L, that is the change in length, or I can say that is the strain. Oh, that is the deformation divided by the original length L. So it becomes what? It becomes strain, and strain multiplied by 100. So that's what known as percentage elongation. Simultaneously, we can also get the percentage reduction in the cross sectional area. A, original cross sectional area, A dash deform होने के बाद जो उसका cross sectional area है, so A minus A dash upon A, that is the change in, that is the strain in cross sectional area into 100. So that is the percentage reduction in cross sectional area. ये भी हम निकाल सकते हैं. Okay, another important point, that is the factor of safety. Any structure which is designed, so the very first aspect is safety. That structure must be safe. Structure fail na ho in any condition. Okay, so in practice it is not possible to design a mechanical component or a structural component permitting the stress up to the ultimate stress, because बहुत सारे ऐसे parameters हैं which we can't consider, which we can't take the assumptions. So in that condition, some factor of safety, so that our design is safe. Okay, it is not failing. Okay, conditions क्या क्या हैं? Reliability. Why factor of safety has to be taken? Because the reliability of material may not be 100%. The resulting deformation may obstruct the functional performance. The loads taken by the designer are only estimated loads, not the actual load. There are certain ideal conditions assumed. So this is why we have to take, whenever we are going to design any structure, any machine, anything else, then we have to take some factor of safety. And factor of safety is what? Factor of safety is nothing. That is the ultimate stress for that particular material divided by the working stress. So working stress means for whatever the load we are designing, that is the working stress. So we have to select the material of ultimate stress, जिसका ultimate stress कैसा हो, which is giving the factor of safety in the range of 1.85 to 6. It depends on the usage. It depends on the type of material. So that is what the factor of safety. I hope in this particular video, I covered the point related to stress strain curve, Hooke's law, percentage elongation, percentage reduction, all the points, limit of proportionality, elasticity, upper yield point, lower yield point, necking, true stress, engineering stress and strain. So thank you very much for watching the video. Thank you.